All right, good afternoon, everybody. System Chalk here with another entry in the Roguelike Dev does the complete roguelike tutorial. Starting July 9th, 2024. It's the 20, sorry, I keep forgetting that it shows the date right at the top. It's 21st at the time that I'm recording it. So I think this means I'm caught up in terms of the videos. I'll upload them and put them onto the Reddit, or well, my post onto the Reddit. I don't really know if I'm, like, the problem with this is that I don't know how much of a contribution this really is to the exercise, save for the fact that there's actually some really interesting projects on here, and I think there can sometimes be some advantage in having somebody who's just doing a very vanilla application. And in fact, this can speak a little bit to some of my motives in terms of doing this. I do know a few viewers, more from the live streams, but have talked about how they want to make games. And that's obviously a very easy statement to make, but it is a very difficult one to put into practice. And so I think projects like this are really wonderful ways that you can sort of push that next step up, push that next step. Obviously, you're not putting this thing on Steam, for $45 and establishing your career. But I think just being able to say, I've made this thing and I have an idea in terms of how you go from nothing to a full project. There's a lot of value in that. Especially, too, if it winds up being something that maybe doesn't appeal to you, right? If there are some factors in here that really don't appeal to what you thought making a game would be like, assuming that they're not specific to this tutorial or to roguelikes in general, I think sometimes being able to diagnose that is also helpful as well, because there's lots of different things that we can do with our time, and sometimes just being able to find out the best use of that time is helpful. So I'll see if I can go through a few. I was also reading some of the comments in terms of this, and I definitely had some thoughts. But in terms of what this is about, one, largely this is a document for myself. Number two, I'm hoping that, I don't think this tutorial is enhanced by the audio book version, which is effectively what I'm doing. But I am hoping that some people might find this a nice little kind of push on the margins to get them participating. And if nothing else, I'm hoping that it's directing a few people to what looks like a very helpful resource to maybe achieve some goals that they were looking for. So in terms of my goals out of this, I want to talk a little bit about some of the troubles that I ran into in the last video and a couple of things that I did to fix them. So first of all, a bit of background. I sort of alluded to a little bit of this, but the best way to describe what I kind of do for a living would be to say that I'm a writer. And maybe more of a writer now than in the previous job. But in the end, while there was always a heavy data component to what I do, that is always done through something like a Jupyter Notebook. So my primary output is going to be something in prose that other people can read and react to and hopefully be informed by, but I probably am not the best judge of that. And so this means that the types of interactions that I'll have with computers, and specifically with programming, will be very different from someone who makes a game that is sort of expected to run on someone else's computer without any kinds of interventions or extra work or something along those lines. And this is one major thing that I sort of want to try and get out of this tutorial here. One, it's kind of just interesting to make something like a roguelike, but number two, this is a chance for me to try and take a look at how a Python project might be structured when I'm not writing, what I called previously before was sort of a Kleenex program in terms of just using it once and getting rid of it. Because of course, again, the primary goal for me is to get a result which I can then turn into a report or something along those lines. And obviously, it's not completely careless. If somebody wants to replicate my results, I expect that I should be able to do that, and so on and so forth. But in the end, I'm not building this whole structure. And very often, the data types will already be a given, just simply because very often I'm working with numbers, or I'm working with one or two transformations to turn something that isn't a number into a number. This is just the nice thing about working on the kinds of problems that I do. It all comes down to numbers, and it all comes down to a specific set of manipulations to those numbers that lead us to something that some might call insight. So one of the things I have tried to do over my time, though, is that once I get past that point of learning how to interact with a Python session and, basically making the computer do what I want, I do want to get a little bit better at it. You can get a lot of efficiency out of just simply learning the software you regularly interact with. I've worked in an environment where Excel gets used a whole lot, and it's fascinating to watch people interact with Excel, people who've maybe been using it for, say, 10 years, and they're still largely copying and pasting items. They're using it almost kind of like a whiteboard with little gray outlines in terms of where all of the little blocks go. And just, to give you an idea, like Excel, I believe some of the highest salaries in Microsoft go to the people who are maintaining the Office programs. And Simon Peyton-Jones, I think, was working on some Excel features. So, this is obviously a very well-respected and incredibly talented computer scientist. He's at Epic now, I believe. But when you have access to a researcher like that, it tells you something that in terms of where Microsoft thinks its value lies. And so I've sort of tried to take that example and push it forward in terms of anything that I learn. When I learn a new piece of software, once I'm able to get the basics down, I do try to do things like learn the hotkeys, and I try to improve. Obviously, I ran into some problems in terms of how I set up VS Code. So part of this is just about getting a little bit better at things. So when it came down to Python, again, my interactions with it are usually going to be in some kind of notebook, either something like IPython or Jupyter. And this doesn't lend itself to the type of program that we would see for a roguelike. But on top of that, it means that when versions of Python go up, sorry, that's not the best way of putting it, but it's like cryptocurrency. The number goes up. But usually, sometimes, we'll not talk about crypto again. But yeah, essentially, I read a book I really liked. I talked about it before, Fluent Python. But I'm also sort of aware enough that all of the people who are really sharp at Python are not sitting around waiting for the new edition of Fluent Python to come out, right? If nothing else, you don't know how Fluent Python gets written if you're just waiting for that to come around. So one of the things that I tried to do for myself was to read the new features of any new version of Python that would come out. At the very least, a new version that would be in Anaconda, which is what I normally use as far as a Python distribution is concerned. And this is one of the reasons why I was wondering about this if and else if. So I talked about this a little bit before, how I said is like, sometimes I've seen this used in a switch statement, but I've also seen people sort of ridiculing people for using these super switch statements. What's going on here? And it turns out what was rattling around in the back of my head was not something like VVVVVV. It was a note that I had read about pattern matching in Python 3.10. So that's a version that was released after this tutorial. This is not me wagging my finger at the tutorial for not doing this thing. But I do sort of wonder if this is... So number one, I'm interested in this because this is an opportunity. When I first ran into it, I couldn't really find a use case. It sort of seemed to me, some of the examples seemed a bit contrived. Some of them, just didn't quite make sense to me. But in this case here, I think this would be an interesting change to make to the program, just so that I can maybe get a chance to use this thing. I think there's also maybe a small improvement that that gets brought in as well, but we'll worry about that. We'll worry about that in a bit. So, first of all, what is pattern matching? So I think it's 636. Yeah. So this is a tutorial. The actual like instructions are in the manual, but I think this will this will work. It actually uses a game example. So it sort of says, you know, what are you doing next? You can imagine a text game, and you could say, look around, right? So you got your verb, you've got your object, we're looking around. And the example that it says, well, you know, it would be very natural to say, look. And if you do that, you're going to run into a problem, right? You only have the verb, you don't have anything else. Sort of the around is sort of implied. And this is one of the examples that it uses in terms of pattern matching. Now, what I'm specifically looking for here would be matching to specific values. So essentially, what I want to do is I'm going to, and actually it even says here, right? You could do that with a chain of if, else if, or using a dictionary of functions. But here we'll leverage pattern matching to solve the task. Instead of a variable, you can use literal values in patterns like quit, 42, or none. This allows you to write, gives this example here. And then also maybe an important point here, literal values are compared with the double equals operator, except for constants, the constants true, false, and none, which are compared with the is operator. So one thing that I think is maybe worth noting here is it doesn't make any claim that this is a more efficient way of doing it. I don't think in this case here, it's really just another option available to us. And there's maybe one thing that I will say I like about the this alternative. But we'll first write this and see how it turns out. So in this case, we'll do match event sim. So in this case, we don't need to worry about the variable. And what I'm going to do here is I'm just going to copy all of this down. Okay, so this is going to need a little adjustment. Oh, we can do these at the time, actually. Okay, so we'll say case. We don't need to compare it to the key. That's already happening. And I'm not putting these in the square brackets because I believe this is specific to the split example. So for instance, remember that we've got a command here. We're splitting it, which turns it into a list. And so if you have a list of only one item, so if somebody says quit, well, we already know that split has turned this into a list. So in this case here, I think the square brackets are not actually going to add anything in here. This is one drawback of me using a tutorial as opposed to reading the documentation. This is definitely the sort of thing that, I know I could be wrong, right? The case actually could require these because the example has just been, it's been following this one example of squares. So I don't see, oh, this is an interesting one. Actually, this all looks a little bit like what we're working with, right? We've got an event. So yeah, this is actually making me feel a little more sure about doing this comparison. In any case, writing it in and seeing if it works probably seems to be the best way. But this is one of the things that I wanted to address from the previous video because actually I should maybe explain this a little bit better, right? Like this is one of these chances for me to learn a little bit more about the tools that I'm using. I'm going from something where I said, I don't know if I don't really know where I would use this thing. And now I'm like, oh, I bet I can use, you know, this item, this particular feature to improve something that I'm working on. And so in this case, just the chance to be able to try something new and see if I understand it and understand a situation in which I might want to use something like this in the future. That to me is worth doing this here. Again, like I said, it's not a finger wag against the tutorial for doing this. This wasn't even an option if they were so inclined at the time that it was written. But for me, like I said, this is a chance to learn a little bit more about the tools that I'm using. So the other change that I'm making here is I'm doing the return. Now, I don't actually know if there is a convention in terms of whether you should have multiple returns like this or if we should return a variable. The thing is, though, we had a variable because we were initializing an action with this none value. But if you take a look, you can just do a blank sort of catch-all case. And that's really where we would want to handle the none, right? So in this case here, there's really no need to have any of the other items. So Is this better? I think there are a couple of virtues for it, right? In this case here, we're saying like, okay, give us a number of these different different actions. I suppose if we were properly working this through, we'd sort of write out definitions in terms of what the, what the program or what the method does, what its arguments are, and so on and so forth. But I don't want to spend too much time burdening the tutorial with extra, I should be writing doc strings. I don't know, match event sim to these items here. In the current context, I sort of understand what this is doing. But overall, it's nice, it's compact, and I can sort of see a situation if I wanted to add another action. So if I wanted to attack, well, we basically have our formula right there. So I'm going to stick with this for a little while, assuming that it works, which is, of course, what we want to try now. So this brings me to the other problem that I ran into. This wasn't so much a problem as it was me trying to remember where I was going. Now, if I hadn't, had that sort of commitment to myself to try and read the, the updates whenever a new version of Python comes out, how else might I have learned something like this, assuming that I wanted to change this? I do have a couple of Python books that I like. So there's Effective Python. There's 2 volumes of it. It's by, I think, Pearson Publishing. And they tend to have little tips. So for instance, instead of doing, map and filter, use list comprehensions. If you don't know what those are, that's completely fine. They usually do have little tips in terms of trying to simplify programs. So what I'd probably do is just take a quick look through the table of contents, see if they had anything about lots of if-else's, and just see whether or not that produced something that, that interested me. But again, this is, it's been about 15 minutes on something that is quite simple. And again, I don't know if people would yell at the multiple returns here, or, if it's better to put it in some sort of a variable. There's nothing stopping us, right, from doing, action equals any one of these and then return action. It's just, I'm doing the return anyway, so why add the extra level? I don't know. Maybe that's something for me to look up at the end of the other video. But the other problem that I ran into was trying to run the program in the inside of VS Code. So if we run the Python file here, I had to switch from input handlers to main because main is where all the action happens. So let's see if this works. Yep, that's working fine. This little devil was the thing that I was missing. So again, I don't really see why you would ever want to, I don't think we need this. Okay, but in terms of requirements, Python definitely. Python debugger was what I was missing, and that's why I had those problems before. Now, I think Pylance, AutoPep 8 are rendered irrelevant by rough. And then Jupyter, Jupyter Cell Tags, Jupyter Keymap, Jupyter Notebook, Jupyter Slideshow, all of those are because I usually use this for data stuff. So, right, for the same reason that I'm using Conda, as opposed to what I think most people would do following the tutorial. Really, I think this is the one thing I'm adding, and I actually really like this one. And then in terms of what I actually needed, this one and this one. I do wonder if I should just turn these off at some point, but that's a me thing for later. Okay, so I think that covers everything that we had done before that I wanted to address. I talk, if I'm going to tell a whole story about how, you should maybe try and learn your tools a little bit and do a bit better in terms of just making your life easier. It would be silly, it would be silly of me to take a problem like the debugger and say, okay, well, we'll just ignore that. So that one was a pretty simple one to fix. And then again, because this was the goal of learning a little bit more about the tools, I was happy to finally find an application for structural pattern matching. And then maybe on my own time, this example will motivate me to go and maybe try a few other things in terms of that pattern matching. Now, before we do part 2 and 3, I did want to take a quick second here and do the roguelike tutorial Reddit post. So there's quite a few here. These are everybody talking about the introductions. I noticed that Hexadecimal is a libtgod maintainer. Actually, it says here, future Python tutorial covering the ECS is in progress. So I wanted to talk, actually wanted to talk about this project in particular, but I'm actually going to go into here because I think this is where, is it Kaisrati? Cogmind is a roguelike. I believe it's early access and you can buy it now. And I know this individual streams, so probably a much more entertaining stream to watch than my own. But in any case, there is a directory of participants. So far this year, we have 40 declared participants in my data, 15 of whom have shared public repos, a higher number of participants than at this point last year, though somewhat fewer repos. I'm sure more will be joining us over the coming week, as happens each year. Not too late to join since the first week is mostly about getting the basics set up. Okay, well, there's a good excuse for me. So Hexadecimal says here we've got a GitHub repo, Python 3.12 using Python TCOD and ECS. So entities are already handled well by ECS, so I have no need to make the entity class as defined in the tutorial, which is exactly what we're doing in here. So this one sort of interests me because I don't know a ton about entity component systems, but I do remember this was part of what Unity called DOTS, the data-oriented technology stack. There's a bunch of improvements that they made to it, and on the surface, some of this seems to be a little bit more like what I first learned in terms of programming back with that scheme. So back when we were using Scheme in school. So, and again, it was just when I learned programming, it was in a proper computer science department. And it's actually not even really Scheme. It was a variant of Scheme. But basically, their focus was very much on turning their students into computer scientists and to specifically get them thinking about certain concepts early. And I think the reasoning was that there's plenty of opportunities to learn a specific language, once you know more, like once you are out in the world, or maybe once you get to your higher levels. Like, if you do a data structures and algorithms course, chances are that they're going to, get you to learn C++ or something like that. And, you'll pick up enough to be able to get what you need. But of course, in school, you're learning certain concepts. And so they wanted to reinforce those concepts and essentially to get people past the idea of saying, if you know how to do an if in Python, you're a computer scientist. They wanted people thinking a little bit more in a specific way about programs. So again, it's not that I don't understand objects or I don't know about them, but they're not necessarily natural to me. And I always tend to find it interesting whenever I see things that remind me of those earlier lessons where essentially we would sort of have these things and what are we trying to represent? We try and represent them in certain types of data, and then there would be all these different relationships that we work out. And again, from whatever I've seen of ECS systems, which seem to be, I've only ever seen them in gaming, but that's also because I probably don't do, unless it's data, I don't really see any other programming that I'm doing. But this is one that I'd sort of like to follow once I've done my own work on here. Where was it? Couch co-op, roguelike. So a lot of Godot. I don't know if this is a response. Oops. Don't know if this is a response to the Unity decisions. Lots of Godot. It seems that people are looking for an opportunity to use the engine. And honestly, there's a local game dev meetup where a lot of people have been very enthusiastic users of Godot, even prior to some of the more controversial announcements from Unity. So, and one of the things that's nice about this is GDScript does have sort of a Python-y flavor to it, although some of the things I really like about Python aren't in it. And I think they've been pretty clear that they never intend to add it. So, but this is the only other thing that I've released to the public was made in Godot. This one is using C# Godot, so I know some people have said that they don't consider Godot an appropriate replacement for Unity based on the C# support. So I'm curious if this might be an opportunity for people to try, try something new or learn, or maybe contribute to whatever gap that they're perceiving. More Godot. C++ one. I don't know if it's using, so it says using the GF2 library, but I noticed it doesn't mention tcod. Hexadecimal here saying learning Git's a good idea, so I've kind of taken Git for granted, but obviously I shouldn't. Somebody's doing one in TypeScript. There was one in Rust that caught my attention. Yeah, lots of Godot I'm noticing. And I also think somebody was doing x86 assembly. Oh, here's one, Rust. Some people already have titles for these things. More Godot. I think I might be wasting too much time. Rust roguelike, but not using tcod, raylib, and flex. Yeah, here we go. Successfully made it through a second week of assembly programming. The map generation algorithm is pretty much the same as in the Python tutorial, and implementing it was pretty straightforward. One difference I noticed is that I tend to split the code into smaller procedures than I normally would in a high-level language because keeping track of everything is a little harder in assembly. Maybe that will change as I get better at this. Here's what the game looks like right now. It's kind of neat. So, again, this has been about half an hour. We haven't done any of the tutorials yet, but I did want to sort of highlight this feature, right? There are people at varying levels of familiarity who are participating in this. And at least for myself, I do plan on uploading this reasonably soon. So if you've been on the fence in terms of making something, making a roguelike, making a game, or participating in this, it seems, as the post says here, it's not too late, and I've gotten something out of it, so I'm hoping you do too. But with that in mind, I've kind of got my basics down. I've got the issues that I had addressed, and I think now the time has come to do part 2. I think I am going to commit the change to input handlers. Let's change the name here. So we won't bother syncing it. We'll do that all at the end. But part 2, the generic entity, the render functions, and the map. Now that we can move our little @ symbol around, we need to give it something to move around in. But before that, let's stop for a moment and think about the player object itself. Right now, we've just represented the player with an @ symbol and its x and y coordinates. Shouldn't we tie those things together in an object along with some other data and functions that pertain to it? Let's create a generic class to represent not just the player, but just about everything in our game world. Enemies, items, whatever other foreign entities we can dream of that will be part of this class, which we will call an entity. Create a new file and call it entity.py. In that file, put in the following class. Again, I want to get a little more real estate. So from typing import tuple, I'm not sure if that's necessary at this point, but we're going to run with it. So remembering that typing was something that's not necessary. It's not necessary, but it is something that will help us get a little bit more clarity in terms of what our intentions are. So class entity to represent players, enemies, items, etc. So even from these definitions, right, you can already get a little bit of an idea in terms of what's happening. So we already said that you always start with self. We're initializing this item here, so we're saying, or this entity, so it's going to have an X and Y position, and those are integers. So it says character, and it's a string. So my guess here is that this is going to be what will distinguish a character, like the main character, the @ sign, versus a potion or an orc, or probably we're not going to represent floors as entities, but you know, basically I imagine that this is going to be something that will actually, you know what? Sorry. This is for me, but I'm going to make the leap of faith in the dark and see if I can let Rough handle all of this. Oh, it doesn't like that. All right, anyways. So my suspicion here is that this is going to be how you change the type of character that it is. And then when it says color and I see a tuple of 3 integers, to me, this would be, you know, assigning the three hex values in terms of, you know, the RGB or whatever. That's my guess anyway. So, my lord. Right, so that's basically like every init that we've ever written. And then we'll define move here. And of course, we already have a move, but there's a difference between moving a symbol on the screen as opposed to moving an entity, which is going to keep track of some other information, which is inside of the inside of the game. So and of course the plus equals was something that we talked about before. We're just saying take yourself and either increment or decrement it by the amount on the right hand side. The initializer takes 4 arguments, X, Y, character, and color, or X and Y are pretty self-explanatory. They represent the entity's X and Y coordinates on the map, presumably following the origin in the top left. Characters the character will use to represent to that entity. Our player will be an @ symbol, whereas something like a troll, coming later in the chapter, will be the letter T. So this is, again, part of where I feel that this is something I should highlight just because of the I'm talking a little bit about the typing. The fact that we've sort of said what these things are and given them good names have already sort of told us what they're probably going to try and do in the game. And color is the color that we will use when drawing the entity. We define color as a tuple of 3 integers representing the entity's RGB values. The other method is move, which takes dx and dy as arguments and uses them to modify the entity's position. This should look familiar to what we did in the last chapter. Let's put our fancy new class into action. Modify the first part of main.py to look like this. So presumably we're adding entity first. Yep. Entity import entity. So we're moving player. This is no longer something that just sort of exists on its own. And under event handler, player is an entity. Oh, right, we need to add the int. "88 spaces. I wonder if oh, interesting. Okay, Rough didn't yell at me for doing that. Don't know where that other comma came from. And then presumably this is a set. Yeah, because it doesn't have colons inside of it. Okay, so currently the entities aren't used, which is why it's giving me the little gray underline. Undefined name player X. Right. We're going to need to change that too. We're importing the entity class into main.py and using it to initialize the player and a new NPC. We store these two in a set that will eventually hold all our entities on the map. Also modify the part where we handle the movement so that each entity class handles the actual movement. So if it's an instance of a movement action, player.move dx action dx dy action dy. Lastly, update the drawing function to use the new player object. So in this case, we take that player entity, we call it up, say, give me your X and Y, and we'll put you in there. So this allows us to sort of say, okay, we'll move this entity all around, we'll do a bunch of different things to it, and in the end, all that root console cares about is, does it know what the entity is, can it pull it out and make it do things. We don't seem to make any use of the entities collection yet, but if you run the project now, only the player gets drawn. We'll need to modify things to draw both entities and eventually draw the map we're going to create as well. I guess I should have run this. Oh no, that's interesting. Name error, player is not defined. Right. Don't remember seeing an error for that, but there we go. Before doing that, it's worth stopping and taking a moment to think about our overall design. Currently, our main.py file is responsible for setting up the initial variables like screen size and tile set, creating the entities, drawing the screen and everything on it, and reacting to the player's input. Soon, we're going to need to add a map as well. It's starting to become a bit much. One thing that we can do is pass off some of these responsibilities to another class, which will be responsible for running our game. The main.py file can still set things up and tell the new class what to do, but this design should help keep the main.py file from getting too large over time. Let's create an engine class, which will take the responsibilities of drawing the map and entities, as well as handling the player's input. Create a new file and call it engine.py. In that file, put in the following contents. Now, this was actually one of the comments that I saw. I was looking for it, but I lost it. I was intrigued by a comment that sort of said they didn't like the fact that there was so much refactoring in the tutorial. And I actually rather like this feature about it. Because essentially what this is saying here is like, okay, you know, you put something in place to try and get your game up and running, right? We know that TCOD is working. We know that we're able to sort of move this object around on the screen. But, you know, the more ambitious the game gets, all of a sudden you have a main program that's going to be, as it says here, is going to be doing a whole bunch of different things. So saying, you know, hey, we've sort of changed the specification a bit, right? We have, am I opening a new Python? Gonna have to think about that. Basically, for myself, one thing that I like about this is that it's sort of saying that, you know, the specification has changed and sometimes it's okay to try and organize things in a sensible way, because I imagine the more that we play, you know, presumably you don't make a game so that you can hate playing it. You know, and the more you play something, the more excited you get. I tend to notice this if you do hang out with game developers or people who say that they develop games. You will often find people talk to them about lots and lots of ideas, particularly if they have a good game idea. And this is the fun part, right? This is the exciting part for people. It's the implementation that's hard. And so I imagine what this is all about is trying to get to a point where you still get excited by new possibilities for your game, And that excitement is not diminished by the fact that you have to pull teeth to try and make everything work. I could be wrong on that, but that's, to me, one reason why I rather like this approach to the tutorial, which is to say that, hey, you know, this thing is becoming big and important enough that we want to make it its own thing now. So anyways, a lot of typing here, so I'd love it if I could play some music, but I have no idea if I have any copyright or music that isn't under copyright. So from typing, port set, and any. It might be worth mentioning there is a convention, to my understanding. So basically, these are parts of the Python standard library. These are third-party libraries, and then this last batch are modules that are ones that we've defined in our own project. And you load them in that order. So our good old friend init. I think this is just entity, but let's make sure. Yep. I don't know how strict the 80 character, 79, 80 character thing is, but I'll maybe take the time, given that I wanted to see if I can just use rough for everything. Maybe one of my little side projects will be to calibrate that to something that I like. Okay, so this one, you know, the init is more or less the same as everything that we've had before. It starts with itself as always, and we define entities, event handler, and player as the arguments that it was given. Nothing too dramatic there. So handle events. So presumably here this, oh no, I was going to say events iterable any. I was going to say presumably this is the entities, but no, this is the events. It says so in the title. So event in events, action is self, event handler, dispatch, event. So this is a tricky one. I think you could actually get by with doing this, and it would, actually, I guess it would have to be not. This is probably more explicit. So obviously you don't want to, the point of coding this stuff is not to show off how clever you are. Oh, this is striking me as a little bit like our case. Well, no, not really, because you know what? We've got a hammer. Let's turn everything into a nail. So what was it? It was match, right? So I wanted to just, the reason why I like doing these adjustments is it actually gets me thinking through the logic of this a little bit. So what are the cases we need to deal with? Well, action can be none. Action can be an instance of action or movement action, or it could be an escape action. So what if it happens to be something it's something that isn't one of these three. I don't think there's anything that's told us. It said it'll accept anything, right? So, hypothetically, there could be an integer in here. So how does the program handle that? It doesn't, right? So it passes over the action none. It passes over isInstance, and it passes over the else if. So what I think I'll do here is I'll make this the sort of catch-all continue at the very end. So isInstance. Right. And then the catch-all of continue. So to my reasoning, this is following the same logic. We're still doing the ifs. Now again, there is the possibility of saying, okay, well, these seem to be exclusive, right? If action is none, if continue. The only thing is I don't see a way where a movement action could be a none. Yeah, movement actions are actions. I don't see a situation where a movement action could be none. So I'm flagging this just because it might be that I come to regret this later. But like I said, this is a chance for us to maybe see if we can reinforce some of the ideas and see if maybe this makes a little more sense to ourselves at least. So def render self console con. This returns none. Okay, so, and again, it's like, well, is there a way we could avoid the loop? Maybe, I don't know, but this does what it's supposed to, so. So effectively, this is just replacing all of this, all of this stuff in main, and this is where it's going to render more than one item. Let's walk through the class a bit to understand what we're trying to get at here. So init, the initialization function takes 3 arguments. Entities is a set of entities which behaves kind of like the list that enforces uniqueness. That is, we can't add an entity to the set twice, whereas a list would allow that. In our case, having an entity in entities twice doesn't make sense. Event handler is the same event handler as we used in main.py. It will handle our events, and player is the player entity. We have a separate reference to it outside of entities for ease of access. We'll need access to access player a lot more than any random entity in entities. Handle events, this should look familiar. It's almost identical to our event processing in main.py. We pass the events so that we can iterate through them, and it uses self event handler to handle the events. Define render, this handles drawing our screen. We iterate through self entities and print them to their proper locations, then present the context and clear the console like we did in main.py. To make use of our new engine class, we'll need to modify main.py quite a bit. So again, more typing. All right, so we're going to get rid of escape action and movement action. So this is worth highlighting because this is now handled by the engine. And in its place, engine. We add engine under entities. And we should stop getting yelled at for the entities, although we've just kicked the can down the road for engine. Okay, so we need to get rid of the printing the player, and instead we will render. We replace this one with okay, and we get rid of everything else here. This is interesting. So, oh. Okay. That looks better. And our main function. So I am intrigued here. So it doesn't like the fact that I import these, and that's interesting. So this doesn't count as a use. I'm sticking with it. I mean, this is all purely because I did these, I did that case thing, but I want to see whether or not this works. Because we have moved the rendering and event handling code to the engine class, we no longer need it in main.py. All we need to do is create the engine instance, pass the needed variables to it, and use the methods we wrote for it. Run the project now. Your screen should look like this. The called match pattern must be a class. Okay. Well, let's do this the way that the tutorial wants it. So I am intrigued by the fact that I'm still getting those yellow underlines. But what I'm most interested in is whether or not this runs, because if it doesn't, interesting. Okay, so this tells me something. Actually, this was removed as well. So I'm just going to take a quick second here and double check. So we say we've got so we're matching this action. So that matches here. So then we say a case, is this true, or is it true that action is an instance of movement action? And yet for some reason, if we do this, something changes in the case. To make this something other than a class. That is going to be definitely one for me to follow up on my own time. And this is, of course, one of the reasons why I do things like that, because intuitive, like, this seems on the surface to be something very similar to what I had done before. And yet somehow when this winds up inside of a case, let me just double check that yep. Somehow by putting this inside of a case, it's no longer, well, I guess it's evaluating the truth of this statement, but it's not treating this the same as before. It's also good to know that the tool that I had, so it did point that out as a problem for me and I just ignored it. So I'm going to leave a little note for myself. All right, our main.py file is looking a lot smaller and simpler, and we've rendered both the player. Actually, sorry, I'm going to make a small adjustment here. Looking a lot smaller and simpler, we've rendered both the player and the NPC to the screen. With that, we will want to move on to creating a map for our entity to move around in. We won't do the procedural dungeon generation in this chapter, that's next, but we'll at least get our class, we'll at least get our class that will hold the map set up. We can represent the map with a new class called GameMap. The map itself will be made of tiles, which will contain certain data about whether or not the tile is walkable, true if it's a floor, false if it's a wall, transparency, again true for floors, false for walls, and how to render the tile to the screen. We'll create the tiles first, create a new file called tiletypes.py and fill it with the following contents. Oh dear. I don't know how I feel about we're just going to get rid of that. Do it the old-fashioned way. So again, telling us that we can hint. NumPy is a third-party library, so there we go. Now this is one of the cases where there might be a problem with the tutorial because NumPy is now NumPy 2.0. But I don't expect that there will be a problem. Tile graphics structured type compatible with console tiles RGB. So I think this comment's just telling us that we're building them a certain way to make sure that they play nicely with TCOD. So this is NumPy's int32. Didn't put the comma. Okay, so one thing about NumPy is this was something that was made for scientific Python, I think, is probably the generic term that people use. So the idea here is that there are languages like C or Fortran, and they work very well. In fact, there are very, very old programs that people rely on to run important things, and it doesn't make a whole lot of sense to get people to rewrite them. And so one use that people had for Python was basically to get these different programs to sort of talk to each other. And someone sort of said, well, it would be nice if we could use Python for this data work. The only problem is right now it's built in such a way that we don't get the same performance as some of these older ones. And so there were a few, I guess, kind of competing projects to try and build something which would be an alternative to writing these. So essentially, instead of just getting Python to sort of communicate with these two things together, it's sort of like, well, let's just write it in Python. And NumPy is the one that sort of seemed to be the one that wound up being the project everybody used. I think it was a unification of a couple of other projects. But the main thing here is that this behaves in a way which is much more similar to those older languages that I talked about. In fact, I'm sure people will yell at me for saying this. It's almost kind of like a Python layer on top of something like C. And this comes with its benefits and also its drawbacks. So one benefit is you do get that performance boost. So it is definitely really helpful to be able to define a whole bunch of numbers into some sort of an array and to be able to perform manipulation on that array and just sort of have it work, and you can rely on it and get it quickly. Use this basically every day at work because, as I was saying, essentially everything is numbers. So but this is a drawback if one of the features you like about Python is the fact that you can kind of put anything anywhere. There's nothing really stopping you from making a list which has a string, an integer, and I don't know, let's say an entity, just for the sake of this example. So the other thing, though, is that there are a number of features of these. Features probably implies something that I don't mean to say, but one thing that is true about representing numbers in those languages is there is the possibility of something known as an overflow. Now, I don't want to spend too much time talking about this because I'm assuming there's two people who would potentially be watching the video up to this point, and that would be somebody who knows better and will point out all the different ways that I'm wrong about this, or somebody who is just, getting started, doesn't need to know this stuff, and maybe doesn't find it very interesting. But I find it interesting. So I'm sure most people kind of know that all of the numbers inside of a computer are sort of represented well, not all the numbers, but most people understand that computers can use binary, right? Ones and zeros, on and off, true, false, whatever you want to think of them. And essentially you have these powers of 2, right? So 2 to the power of 0 is 1. 2 to the power of 1 is 2, 2 to the power of 2 is 4. And so with that, you could say, what's the highest number I could represent? Well, if I take 1, 4, and 1, 2, and 1, 1, then I get 7. And keeping in mind that all of those values set to 0 are 0, that means I can represent 8 different numbers. And then as you start adding more digits, which again only need to be a 1 or a 0, you start expanding the possibilities quite a bit. So the 32 here represents those number of all those switches that you can sort of turn on or off to represent a certain number. Int32 is a big number. I can't imagine a situation in our roguelike where we would ever need the 32, although who knows, right? At least in terms of like entities and damage or something like that. I guess we could try and do some sort of Final Fantasy thing where the numbers become preposterous, or a clicker game. But there's an interesting question you could ask is like, well, what about negative numbers? How do you represent that? Well, one of these might be to say, well, we just know that it's a negative number. So, maybe we'll make a variable, call it negative number, and, we'll represent that as a we'll represent that in the same way, all those ones and zeros. And, we'll just make sure we write our program to, to treat the negative number as a negative rather than a positive. And this sounds silly, but this is actually a very practical consideration if you consider accounting, right? Because there are some fields in accounting which are always going to be considered negatives. And you do actually need to pick, am I going to explicitly represent this as a negative number, or do you just put a number inside of it? And the logic of the program is going to go up. So for instance, if we talk about costs, right? So let's say wages that were paid. In terms of an accounting statement for a firm, that would be a cost. That would be a negative number. And yet for the employee, that's going to be a positive number, right? You never want to go to work at a place and find out you owe them money for working there. So, these sound like silly examples, but you can actually sort of see how even the same number from two different perspectives will have two very different interpretations. Same way that banks see lending to you as an asset and you lending to them as a liability, whereas of course we have the complete opposite view of this. And so again, it sounds kind of silly, but in this case here, you can imagine an accounting program will in fact it will be consulted by both parties, and so needs to sort of think about how it's going to represent these things. And I don't even know if there is a standard in terms of what people think is better than, if one is better than the other. It just happens to be something that I imagine is improved just by having that consistency. So anyways, that's a digression on a digression. Where it becomes interesting is this idea that you can say, it's like, okay, well, maybe we don't like this idea of having the context matter, right? I can think of a lot of situations where maybe we would be misled by that. So we want to have this idea of being a positive or negative number attached to the number itself rather than the variable. It's like, well, that's fine. What you can do then, in fact, this is what the integer is here. What you'll say is like, okay, well, we're going to use 31 of those bits to represent the number itself. And then one of those bits is going to tell us whether it's positive or negative. And so, you can go one direction for the negatives, you can go the other direction for the positives, and you just use one of the bits to decide which side that you're on. And then, of course, if you can say, well, it's always going to be positive numbers here, you can use what's called an unsigned integer. And what that does is, instead of splitting your number between positive and negative numbers, you get to, to just have, the big positive number, or you can move it down a step. So for instance, if we're thinking about that number that could only represent 8, losing half of that to negative numbers in a situation where we know we wouldn't have a negative number, that's actually quite a big loss. And so that would maybe be a situation in which we want the unsigned integer, simply because it allows us to do more with less. So the reason why I'm going on this big long rant here is that in terms of Python, you don't need to worry about what's called an overflow. I think what happens in Python is it just keeps trying to represent the numbers and making them bigger and bigger until it runs out of memory. That's not true for NumPy, and that's because that's not true for C. In fact, I think in the case of C, it doesn't even have a standard size for, I think it's integers. Anyways, there's one of the data types in it, depending on the type of hardware you're running on, I believe there will be a difference in terms of the number of bits that's used. And so there is if you've read Sid Meier's memoir, there is a famous and not true story about civilization, which said that India, which is led by Gandhi, had a maximum passiveness rating. And making Gandhi more passive led to an overflow error. And essentially what happens, again, you only have so many numbers to represent these things, so it applies the adjustment to go down. And because it tried to go down, the numbers just rolled over, and instead it actually gave a maximum aggression value. Now, again, Sid Meier himself has been very clear that never happened. In fact, I've seen on Twitter some people refer to or tell the story and say that they have actually heard this story told inside Firaxis. So I guess it's just one of these things which is too good to check, to be completely honest. But that's probably one of the more memorable examples of an overflow. Now, I can say in my own research, I have run into the overflow problem specifically in NumPy. And it was because, again, I tried to get a little too clever and save some space, basically. And the number rolled over. And I'm like, I'm pretty sure you don't get negative numbers when you square something. And then take a look, and sure enough, it just wound up being too small. In fairness, actually, I wasn't specifically setting data types to be too small. What I was doing was I was importing them from another program which had already made them small. But I think it's still my blaming on me, because I did run the compress function on that program before. So I wasn't trying to show off in Python, but I was trying to make my life easier in terms of storage. Neither here nor there. But these are the sorts of things. Oh dear, this is a bad sign whenever the screenshot comes up. So all of this is to say is that this is an example where, because you're using third-party libraries, a little bit like TCOD, these are the situations where sometimes you can run into counterintuitive behavior, right? Just like how I thought, oh, I should be able to use this switch. This is a situation where there might be weird behaviors. I'm not expecting from a 32 int, but these are the sorts of cases where it can be like, okay, this is where suddenly we're getting into weird and wonderful tools. And outside of the context of a tutorial, you may just run into something that doesn't work the way that you were expecting, and you're maybe scratching your head in terms of what went wrong, which again is the reason why I like doing stuff like this, because I would rather run into an unexpected result when it's safe to do so, rather than have like a deadline and not understand why my program isn't running, or why it's giving me an answer that I shouldn't. And again, even in the data example, it's good that I got a negative number, because if it was a positive number, there's a chance that I maybe wouldn't have questioned that result. All right, sorry. Too long spent talking about overflows. Tile struct used for statically defined tile data. So I think what it's doing here is it's just defining a few different states that the tile can be in. So I mean, obviously you can get that from Walkable and such. So this one I think is playing around with the internals of TCOD. It's basically saying, okay, we're going to give you a bunch of values that you just like, and this one is going to be more for us to say that you need to know if a tile can be crossed, or whether or not, I've noticed that there's a dark here, so whether or not you can see. So, and again, NP bool, just taking advantage of NumPy rather than the internal Python ones. I think if we didn't have the NP here, we'd still be fine. Although I think it did say that NumPy was a dependency for TCOD, so chances are there's a reason why all of this is using the NumPy stuff. Right, so that's just telling us it doesn't block FOV, so this is already preparing us for sort of a fog of war kind of a feature. And the comment here says, okay, so you've explored a room, we want you to have an idea of what was there. So in this case, it says you get a different image based off of something that you've seen before, which I like. All right, function for new tile. So this little star here is, well, it actually says enforce the use of keywords so that the parameter order doesn't matter. So I don't need to explain. So I think what's going to happen is if we don't specifically say walkable, transparent, and dark, it's basically going to ignore that that input, so far as I can tell. And walkable is an integer, transparent. Now that's interesting. Isn't this supposed to be a bool? I'm going to probably take a little bit of time to unpack what's going on in this. Oh dear. Okay, right. Okay, so that should fix that. So this, okay, so I understand we want to be really clear in terms of defining these things. So walkable is an integer, and yet this is a Boolean. Transparent, again, is a Boolean. Dark I can sort of understand, but it's an integer and then two. So these, I think we've previously seen, are colors. And I'm guessing that maybe this is saying, here's what it looks like when it's dark, here's what it looks like when it's bright. But I will confess, I'm actually trying to understand exactly what's going on here. So I'm definitely going to be interested in seeing what the commentary says on this one. And then finally, floor, we're going to take advantage of our function right away. Fascinating. I think this gives a character representation of the string inside. Although if that's true, we're representing blank tiles. Oh, I get it. Right. So I think the old Rogue used to represent walls with kind of like this. And I imagine what this is doing instead. Well, no, that doesn't make sense either. I was thinking that maybe it would just be like a solid block. Well, we'll see what happens when we look at the game. So, like I said, part of this for me is trying to see if I follow the project. So, like, this is one of the cases where I really want to read the text associated with this code here, because there's a couple of cases where I'm wondering where they're going. So, for instance, I sort of wonder why you wouldn't do that. Actually, I guess I need to, yeah, lowercase. I'm actually going to change this just so that I can see what happens. All right, that's quite a lot to take in all at once. Let's go through it. Tile graphics, structured type, compatible with console tiles RGB. dtype creates a data type which NumPy can use, which behaves similarly to a struct in a language like C. Our data type is made up of three parts. ch, the character represented in integer format, will translate it from the integer into Unicode. FG, the foreground color, 3B means 3 unsigned bytes, which can be used for RGB color codes. And BG, the background color, similar to FG. Okay, that actually makes sense, right? So 3 unsigned bytes. We'll take this new data type and use it in the next bit. Oh, now that's interesting, right? Oh, no, hang on. Sorry, I was wrong. We've got these. So it does say NP bool for these. Actually, it makes me wonder. Can I insist on them being NP bools? I might be making heartache for myself later, but because I don't believe this is an NP bool, but it might be coerced into one. We'll see. We'll take this new data type and use it in the next bit. So now it says take this new data type and use it in the next bit, but I'm not quite sure that's true. There's no way that these... Oh, no, we use it in graphic DT. Never mind. I'm gonna keep quiet. Although this makes a little bit more sense now. If we've got the character, the character RGB and RGB, which of course also suggests that these should be maybe other data types. So I'm probably just going to make myself sad by insisting on these. I should probably change them back. All right, this is yet another D-type, which we will use in the actual tile itself. It's also made up of 3 parts. Walkable, a Boolean that describes if the player can walk across the tile. Transparent, a Boolean that describes if the tile does or does not block the field of view, not used in this chapter, but will be in chapter 4. Dark, this is our previously defined D-type, which holds the character to print the foreground color and the background color. Why is it called dark? Because later on we'll want to differentiate between tiles that are and aren't in the field of view. Dark will represent tiles that are not in the current field of view. Again, we'll cover that in part 4. And this is the part I want to see what's happening here. Why did they define these things the way that they did? This is a helper function that we'll use in the next section to define our tile types. It takes the parameters walkable, transparent, and dark, which should look familiar since they are the same data points we used in tile DT. It creates a NumPy array of one of the just tile DT elements and returns it. Okay, so I'm not going to put the NumPy stuff in. I am, however, going to say that these are still Booleans. I do wish that they had actually unpacked a little bit why they made these ints. I can understand not insisting on NumPy stuff because in the end we're doing these inputs. So ord's going to be, I think we can actually just, yeah. So it says right here that this is returning an int, and we know that this is a bool. This is not an NP bool. And I can obviously make it so that it's an NumPy1, but essentially this is us talking to this new tile, and then this new tile is turning this into a tile DT, at which point it's going to presumably convert it into all the different types that it needs. Finally, we arrive at our actual tile types. We've got floor and wall. Floor is both walkable and transparent. Its dark attribute consists of the space character. Feel free to change this with something else. A lot of roguelikes use the hash symbol. And it describes its foreground color as white. It won't matter since it's an empty space, and background color. Wall is neither walkable nor transparent, and its dark attribute differs from floor slightly in its background color. Now let's use our newly created tiles by creating our map class. Create a file called gamemap.py and fill it with the following. I'm going to try this. Whoa, wrong button. I really can't change the name, huh? Ah, cool. I learned something. And of course, we don't have any standard library imports. We're doing third-party imports. And now we're importing our tile types. Our old friend init. Trying to remember what full does. Return a new array of given shape and type filled with fill val. Ah, right. Okay. So it's giving us a matrix filled with a floor. And then order F is the, we remember that from before. That's to make sure that its origin is in the top left. And here we're sort of arbitrarily choosing 30 to 33 to put a big wall in the middle. So this probably makes sense, right? We're making a game map, so we're including a method to decide whether or not we are in bounds. I don't know if this is a Python thing or not, but I know some conventions have it so that you, I think it's is where you always start with something that returns a Boolean, but I imagine that's a very old-fashioned convention. So in this case here, we can say so long as you can be at 0, but you can't go to the negative numbers. And same story with height. I feel like there is a, well, I guess there's different, like there's a clamper variation on it, but that's not really what it's asking. It's asking if it's within these boundaries. So I thought there was a function that actually did that for us already, but I'm probably wrong. And render the map. Cool. So this one, it is saying, okay, take the console. It's got something called tiles RGB for the tiles that are between 0 and width. So in this case, my understanding is this is the whole board, although I would not be surprised if at a later point they add something like an inventory or something that might be on the screen that's not the playing field. And basically make them dark. Let's break down game map a bit. Define init. Okay, this is what we've done a bunch of times. The initializer takes width and height in integers and assigns them in one line. With self tiles, the self tiles line might look a bit strange if you're not used to NumPy. Basically, we create a 2D array filled with the same values, which in this case is the tile type's floor that we created earlier. This will fill self tiles with floor tiles. Self tiles 30 to 33, 22. Tile type's wall creates a small 3-tile wide wall at the specified location. We won't normally hard code walls like this. This wall is just for demonstration purposes. We'll remove it in the next part. In bounds. As the docstring alludes to, this method returns true if the given x and y values are within the map's boundaries. We can use this to ensure the player doesn't move beyond the map into the void. And then render using the console class's tiles RGB method, we can quickly render the entire map. This method proves much faster than using the console print method that we used for individual entities. So just as a note here, this would be one of these points where maybe if I wanted to go out and make my own thing independent of this tutorial, this is a function that I would want to read, or method that I would want to read read up on. So when they're saying that, you know, you don't need to render things one by one, you can use this tiles RGB method. This is the point where it's like, okay, so what's the difference between these two? Why would I want to use one as opposed to the other? And rather than just sort of take the tutorial's word for it. But obviously I can't, you know, you don't want to turn every single idea in this into sort of a battle. I want to, where I can, learn as much as I can about the tools that I'm using, but not sort of go down and, you know, demand to see the source of everything inside the library before I ever use it. With our game map class ready to go, let's modify main.py to make use of it. Also, we'll need to modify engine to hold the map. Let's start with main.py though. Also, what I'd probably do myself, as I keep adding these individual elements, I might actually, for myself, I would maybe do like one commit for each of those, because there's actually going to be quite a bit. Like, imagine writing the commit message for all of this stuff that we've put in here, right? I guess to a certain extent, you know, we've got the tile types and the game map, those kind of sit together, but then we also have, you know, entities and an engine now. And like, this is definitely a big super commit message that I'm writing, which is either going to leave out some details or it's going to be, you know, it's going to be something that someone just like clicks on and heaves a heavy sigh seeing it. All right. Let's get to our changes to main. So from game map, import game map. So this is anticipating that thing that I said earlier, right? We now have a map width and map height, and that's different from the screen width and screen height. So after entities, we add game map. And then we change entities. So we've got an event handler. I think we probably need to change the engine. I always thought rough would adjust the length here, so I think normally what we would do would be something like, or I guess something like this. Oh, I'm really... That's fine. I mean, I'll be honest with you, I've never been big on the line length thing. Okay, we've added map width and map height, two integers which we can use in game map to describe its width and height. The game map variable holds our initialized game map and we pass it to the engine. The engine class doesn't yet accept a game map in its... That's interesting, actually. So I'm tossing it a value that it can't handle, but I'm not getting an error. I don't know if there's a way for me to reset. Again, another thing for me to think about. Okay, hold our initialized game map, and we pass to the engine. Engine class doesn't yet accept a game map in its init function, so let's fix that now. So after entity, from game map, import game map. Under its init, and then self game map equals game map, and instead of a player move. Oh, interesting. So this isn't just sort of a trivial little, hey, we're going to add this to the rendering. This is actually putting some constraints in terms of how we can do our movement. So if self game map tiles walkable, so I'm going to unpack this in a minute. I just want to make sure that I write it out first. And I'll do the render. Okay, so if our action was a movement action, so we're going to take our tiles. So again, this is because we're dealing with a two-dimensional, I think we're working with a two-dimensional object. Let me just verify that. So tiles. You know what? I think I am a little confused as to what this is doing, actually. So we've got a 2x2 grid, and it's full of floors. So what I'm trying to take out of this grid is walkable, which doesn't seem to make a whole lot of sense to me. So essentially I'm saying take out of tiles walkable and an X and Y position. So essentially this is the place where we're going, right? We've got our X position, we've got our and our delta, and we've got a Y and the delta Y. And so essentially we're saying is like, okay, so as long as this thing isn't, as long as this thing is walkable, do the move. But I'm actually not quite sure how we get to walkable here. I'm guessing that there is another change that gets made. Nope, apparently not. All right, we've imported the game map class, and now we are passing an instance of the engine's initializer. From there, we utilize it in two ways. In handle events, we use it to check if the tile is walkable, and only then do we move the player. In render, we call the game map's render method to draw it to the screen. If you run the project now, it should look like this. So I am going to run it so I can see what's going on. All right. Not a huge surprise we had an error. So what's the deal here? Line 46 in main. Well, that doesn't tell me anything. So line 39. Okay, so it's tried to render something that it didn't like. On 34. I rely too much on tabs. Game map doesn't have a render. Okay. This tells me it does. I'm going to save all of these to make sure I'm not losing my mind. I guess we can close out input handlers and actions at this point. Okay, so this one is a little trickier than I thought before. So we've got game map here. We've defined a method called render. Render takes itself, as it always does, and a console. So seems to me that this is fine. Game maps should take a render. We are in, where were we? Engine. So inside of engine, engines, so this is a game map. We're good to go there. Engines define a render, specifically taking a render on the game map here. So this should be this game map render. These are the ones that actually drive me a little crazy because conceptually, this makes total sense. But clearly somewhere in this in this whole chain, there's something not working the way it's supposed to. So we've got the game map here. We define this engine. So I think the thing that really catches my attention here is that it's referring to it as an attribute, and it's not supposed to be an attribute. It is supposed to be a method. Okay, so we've got self, game map. Interesting. Right. So these were functions defined in init, not defined in game map. Hey, what do you know? All right, how embarrassing. So we can run through our little yellow fellow. Can we run through the wall? Okay, this fascinates me. I have no idea how the tile thing works, but it obviously does work. Right? Like I'm not able to walk into this. Oh. Now that's interesting. So we were able to walk out of bounds. I wonder if that's dealt with elsewhere. I'm not going to fix this right now, but that's actually really interesting to see. Okay, so a few notes for myself here. One, I'm probably going to want to check out Rough and see if I can make this work a little bit closer to what I personally would want. Got past that rather silly little bug that I introduced by not tabbing. I want to sit down and have some quality time and understand, excuse me, how game map tiles work. So this is actually one of these cases where setting a breakpoint in the debugger, I'm actually going to do that right now. I can examine the variables and see exactly what tiles looks like. I think that's going to be how I try and find some sanity there. And this is, again, this is the difference between sitting down and just passively, like copying and pasting, or just like working through this tutorial and sort of plotting through in terms of the setups and things like that. This is one of the reasons why I take the time to sort of talk through the code that's going in, because I feel that I will learn something more helpful if I take the time to sort of, again, do that whole, I am expecting X to happen, oh, Y happened. Was that supposed to go on? You have an example of that actually also in terms of the checking if it's walkable. Yeah, so here it tests. Yeah, actually this is interesting. So the problem here is that it assumes that this value is going to be bounded by the map, but there's no reason to think that that's actually the case. So I think there's some sort of protection that needs to be put in. Anyways, something for me to think about. But yeah, these are the cases where I'm like, I'm not going to spend the time on the video because obviously it's one tutorial. There's 2 for this week, and I do want to get to the end of this video. But this is definitely something where I want to sit down and I want to spend some time figuring out exactly what's working, and then a little bit like some of the problems that I ran into, I can report back. The game is working, so and that's what matters. Okay, the darker squares represent the wall, which if you try to move your character through should prove impenetrable. And before we finish this up, there's one last improvement we can make thanks to our new engine class. We can expand our action classes to do a bit more of the heavy lifting rather than leaving it to the engine. That's because when we pass the engine to the this is because we can pass the engine to the action, providing it with the context it needs to do what we want. Here's what that looks like. So yeah, this is action. Oh, I think I just got rid of those. Okay. I'm going to take a quick second here when it says future import annotations. I want to see if those are in fact future. Actually, I wonder if it'll just throw a interesting. Tell you what, this is going to be another one that I follow up on. I'm going to follow the tutorial, and then we'll see if we can maybe do a little cleanup on here, because I don't know when that might have changed. I'm curious why it's importing engine and entity if only there's type checking going on. I'm not 100% sure what's happening there. And perform. Now, it's maybe worth mentioning here that, so we're changing the base. Like, this is action. This is going to follow through all the way to escape action and movement action. So we're saying that engines and entities are now part of this class. None perform this action with the objects needed to determine its scope. Engine is the scope. Action is being performed in. T is the object performing the action. Would must be overridden by action subclasses. Right, so if you ever actually perform an action, if you try to perform an action and you haven't done it inside of these, the game's going to tell you to take a hike. So basically the same behavior as before. And we now add okay, destination x equals dx plus self.dx, best y entity y plus self dy, not engine game app inbounds dest. How much you want to bet that solves that bug that I just ran into? Darn. Okay, that seems pretty straightforward. This is also kind of a nice thing here, right? Notice that for, this is one of the advantages of classes. Like I said, just because I'm not familiar with classes doesn't necessarily mean that, or I'm sorry, I shouldn't even say not familiar. Just because I don't use classes a whole lot doesn't mean I can't appreciate what they do. In this situation here, notice that we added perform, actually, hang on. I was going to say something, but then I caught myself. No, there was something. There wasn't actually a big savings that I got out of this. Never mind. But still, I'll just say we implemented perform, and I suspect that this is going to fix the bounds. That's all I needed. Now we're passing in engine and entity performing the action to each action subclass. Each subclass needs to implement its own version of the perform method. In each case of escape action, we're just raising system exit. In the case of movement action, we double check that the move is in bounds and on a walkable tile. And if either is true, we return without doing anything. If neither of those cases proves true, then we move the entity as before. So what does this new technique do for us? As it turns out, we can simplify the engine handle events method like this. So first of all, we can take out the actions. And we can do, instead of movement action and escape action. Oh, so. Okay, it says, much simpler, run the project again, and it should function the same as before. With that, part 2 is now complete. We've managed to lay the groundwork for generating dungeons and moving through them, which, as it happens, is what the next part is all about. So let's run this and see whether or not I run into that same problem. So first of all, make sure the buttons work. They do. Can't walk into the side. There we go. Protects us from checking something outside the bounds. Cool. All right, and escape works. So we did finish part 2, so we got a lot of stuff to change here. Did I just add everything unintentionally? Okay, well, that's fine. I'm just going to say completed part 2. There's too much. And I guess in this case, I'll commit and sync. And this is because, I mean, this is as long as the previous episode was, and I only got through one of the 2 that I wanted to. I just want to go out for a little bit. I'll try and do this last part today, excuse me, because I know next Tuesday is going to be the next chance I get to work on this, but that's also going to be when the next week passes. So again, there's a few things for myself. One of the reasons why I want to write these to-dos is just to make sure that I can explore some things on my own. So, for instance, I do want to see what that story with the Switch is, but that's maybe not a deal breaker. Like I wouldn't hold off finishing the rest of this week's work on that. I guess I already said that the out of bounds was handled. So I suppose the only other thing is, like, right now there's type annotations. This seemed in the documentation that there were references to type annotations that weren't in the future. So I just kind of want to see if there's a chance for me to import annotations from a different place. And again, this is not saying that there's something wrong with the tutorial. It's more to make sure that I'm not just... I'm sort of acknowledging the fact that Python has gotten some new versions between when this tutorial was last written and now, and that it might be a good idea for me to just make sure that I'm on top of the language. If this is something that's coming into the future, I might want to know when that future arrives so that I can take advantage of these if I find it helpful. But anyways, thank you very much for watching. The next video, I suspect what we'll do is we'll go on to part 3. I'll see if I can maybe keep it less than 2 hours, but it depends on how the process goes. And I think once that one's done, I will upload all the videos onto YouTube and then, I don't know, see whether or not the world finds any of these worthwhile. But if you're here, it means you did, or at the very least, you lost access to your mouse to move elsewhere. So thank you very much for watching. We'll see you in the next one.